Hello and welcome. Today's presentation is brought to you by Science Visualized. And today we're looking at the reaction of carboxylic acids with nucleophiles. What are carboxylic acids? Carboxylic acids contain an alkyl group, that one which we will call R, a carbonyl compound here, so we'll call it carbon double bond oxygen, and an OH. In this case, the alkyl group is here, R, and then carbon double bond oxygen and an OH. Same thing here, the alkyl group is that will be the R, and here that will be the R. So I can represent all these structures by using a generic carboxylic acid, RC double bond O, OH. Now the question is, how do they react with nucleophiles? So plus a nucleophile, and this is usually done under acidic conditions, or in some cases under basic conditions. What will end up happening is that the nucleophile, using its lone pair of electrons or a negative charge, will attack the electrophilic carbonyl carbon, and then at the same time the double bond electrons will move to oxygen to become an O minus. Now you have an O minus there. You still have the OH there, but now you have connected the nucleophile to that carbon, and this is called the tetrahedral intermediate. Now if this is under basic conditions, the next step will involve the minus charge on oxygen coming back to form a double bond, and at the same time the OH group leaving as an OH minus, which will result in a double bond to that oxygen, and now we've lost the OH and we're only left with the nucleophile. So I'll go ahead and label this as under basic conditions. Under acidic conditions, you start with protonation. So remember, under acidic conditions you have plenty of protons or hydrogen ions, and the first step will be the protonation of that oxygen. So it will connect to that hydrogen ion, and now you end up with protonated oxygen, which has a formal positive charge. The next step now will be the addition of the nucleophile, and now we cannot use a negatively charged nucleophile. We have to use lone pair of electrons on the nucleophile because it's under acidic conditions, and the lone pair of electrons will attack the electrophilic carbon, and then the electrons of the double bond, one double bond electrons, will flow to oxygen to neutralize the positive charge, and now you end up with OH without a formal positive charge there, but now the nucleophile has connected to the carbon, and again that's a tetrahedral intermediate. So the next step will involve protonation, so plus H plus, and that will protonate this oxygen, and now you have that oxygen protonated, and therefore it has a formal positive charge. The next step will involve this lone pair of electrons coming back to form a double bond while kicking out water, which is now a stable leaving group. So this will give, now we have a double bond to that oxygen. We lost water, so the only thing we have now is a nucleophile here, but we still have the hydrogen connected to that oxygen and a formal positive charge on that oxygen. So the last step will be minus H plus. So you end up losing that proton, and that will give you a neutral product. So we see that under both acidic and basic conditions, you end up replacing the OH at the acyl position with a nucleophile. So again, I'll write this reaction here, OH plus nucleophile, and that will give you the product as RC double bond O, and now at the acyl position you have the nucleophile. Now types of nucleophile. If you use water, H2O, that will lose one proton because it's a neutral nucleophile, and you end up adding OH. If you use an alcohol, ROH, again we'll lose a proton, so you end up adding OR. If you use ammonia, NH3, you end up losing one hydrogen, and therefore you end up adding NH2. So that means if you use water as a nucleophile, you end up adding the OH, so you end up with a carboxylic acid as a product. So in this case, because we're starting with carboxylic acid, then it doesn't change. But if you're starting with something like an acid chloride, where you have a halogen in this position, then you end up forming a carboxylic acid. If you use an alcohol, you add an OR, so you end up with an OR at that position, and that gives you an ester. If you use an NH3 or primary or secondary amine, you end up losing one hydrogen, so you add NH2, and that gives you an amide as the product. Thank you very much for your time. Please support the channel by subscribing.